Yes. The last, chapter? Yes. Yep, test is next Thursday. Okay. Remember also, I did say as we get to the end of the chapter, so we have different ways to solve triangles. You use SOHCAHTOA to solve a right triangle, oblique triangles, which are non-right triangles. You use law of sines or law of cosines. But I will not tell you in directions, use this to solve the triangle. You have to determine what to use. So as we're working through these, as we're building, just keep in mind what it looked like when law of sines would work versus now if law of sines doesn't work, we have law of cosines as well. So as we did talk about, and this shouldn't be something you have to memorize because I did talk about if you're trying to set up law of sines, you can hopefully easily tell whether or not it's going to work. You need to have a full ratio and then you need to be able to fill in parts of the other ratios for law of sines to work. So law of sines can be used to solve a triangle if you know, thinking back to Friday, if you know two angles and a side. So that could be the ASA case where you know two angles and the side that's in between them. It could also be the AAS case where you know two angles and a side opposite one of the angles. And then we also used law of sines yesterday for the case we were given two sides and an angle opposite one of the sides, so the SSA case. But that was the case that you just have to be very careful of to determine how many triangles are possible before you begin. So then law of cosines can be used as long as you know the measures of two sides and the included angle. So that would be the side angle side case. So law of sines cannot be used in that case. You'd have to use law of cosines. Also, if you know all three sides, so the SSS or side, side, side case, you can also use law of cosines for that. There's no way to solve a triangle if you aren't given at least one side. So notice all of these cases give you at least one side measure. So if you're just given three angles in a triangle, there's no way for you to find what the side length should be. You have to be given at least one side. So here are the formulas for law of cosines. I will say you don't have to memorize law of cosines, but these are just three different variations of the same formula. I'm not going to be giving you all three, or I might even give you the first variation, but then you have a problem like number one that isn't even in terms of A, B, and C. So you have to understand how to take the information you have and apply it to the formula, meaning you have to have an understanding of what the formula is saying. So in triangle ABC here, we have sides ABC, angles ABC. So three different variations of the same formula. So the formula that involves angle A, so this is kind of how you look at these. The formula involving angle A says the side opposite the angle squared, so A squared should equal, need it quiet please, should equal the sum of the other two sides squared minus 2 times the other two sides times the cosine of the included angle. And that's kind of the same variation for the rest of these, but it depends on which angle you're referencing in the problem. So we're going to apply this formula, use this formula, and then there will be some questions. There's one question on, part of the lesson. There's a couple questions on your assignment where you're not told should you be using law of sines or law of cosines, but you have to determine which one to use. So if we are solving, for example, one triangle FGH, and we're given angle G is 82 degrees, side F is 6, and side H is 4. So solving the triangle, find everything that's missing. So I'm going to sketch triangle FGH, call this angle F, top angle G, this angle H. So it doesn't really matter where you put the angles, but now where I put the sides does matter. Side F is opposite angle F. Side G is opposite angle G. Side H is opposite angle H. And then I'll fill in what I have. So I know angle G is 82. And then side F is 6, and side H is 4. So notice what I'm given. I'm given two sides and the included angle. So this would be the case of SAS. I first want to show you, though, because when you're trying to work through this, or I guess I don't really have to show this, but if I set up law of sines, because I will say between law of sines, law of cosines, law of sines is definitely, well, in my opinion, easier to use, and that's the general opinion I get from students. But I'm going to just set up what law of sines would be in this case. So it'd be sine of F over side F would equal sine of G over side G is equal to sine of H over side H. So say you didn't know what method to use to solve this triangle. Obviously, we can't use SOHCAHTOA. Why does law of sines at this point, based on what I'm given, why can I not use it? Or if you're looking at it and saying, I don't know why you can't use it, then it's a good thing to discuss. So why can law of sines not be used at this point? Okay? Right, we have one angle, so there's no way right now for us to find the other two any other way, and we don't know the side opposite the angle. So you have to know an angle and its opposite side, or at least be able to easily find that. In order for law of sines to work, you have to have a full ratio, and right now if we filled in what we have one thing for each ratio, but we don't have a full ratio. So we can use this later in the problem, we just can't use it in the first step. So then I need to use law of cosines, and so I'm going to put step 1 here. The first thing I should find using law of cosines is I should find the missing side. So when you're given the case of two sides and the included angle, the first thing you should work on finding is the missing side. And part of why you have to do that is because we don't know either of the other angles. So if you tried using a different variation, you just wouldn't have enough information. This is really the only option you have of what to find first is that missing side. So we're going to find side G first, and we're going to use law of cosines to find that. So I'm going to set up what law of cosines looks like in relation to F, G, and H. So if I'm referencing angle G, this is what the formula would look like. And I'm just writing a different variation of this. It would look like G squared, so the side opposite the angle I'm given squared, equals the other two sides squared. I'm going to write the formula, not plug in numbers right now. So F squared plus H squared minus 2 times the other two sides, so 2 times F times H times the cosine of the included angle G. Okay, so that's how to set it up with the variables that I have. If you needed to, based on whatever variation you're given, if you needed to fill in next to those A's, B's, and C's so that it was easier to use, you certainly can do that. Just make sure when you're giving your answers, you're giving it in terms of F, G, and H. So now, with this variation, I can substitute in what I know. So I have G squared equals, since F is 6, F squared is 36, plus H is 4, 4 squared is 16, minus, I'm going to multiply 2 times F times H right away. It is multiplied by cosine of G, but I'm just kind of simplifying a little bit as I go. So 2 times 6 times 4 would be 12 times 4, so 48. So 48, and then cosine of angle G is 82 degrees. And that 48 and the cosine of 82 are multiplied together. And now this can just be typed in the calculator. However, before I type this in, I actually want to discuss something. When I type this in the calculator, that's going to equal G squared. How am I going to solve for G? Take the square root. So what I'm actually going to type in is I'm going to type in the square root of this entire side and just make sure that entire side is within the parentheses when I type it in. So I type in the square root of, notice how that parentheses comes up, so I just have to make sure all of this is within the parentheses. 36 plus 16 minus 48 cosine of 82. I'm going to have to close the parentheses for the 82 and then close the parentheses for the square root. Hit enter. And we'll round, like we did yesterday, we'll round angles to the nearest angle measure, so whole number, and then sides to the nearest tenth. So about 6.7 is side G. So again, make sure on your calculator that you're able to get that answer however it is that you have to type it into your calculator. Okay, so I'm looking for, let me just label this here, I need angle F, angle H, and then side G, and I found side G is 6.7. So whenever you have to use law of cosines, I still have two angles to find. I could use law of cosines again to find one of those angles, but I will say this. Whenever you have to use law of cosines, you should only have to use it once. You should only have to use it in the first step. Because now, the entire reason we couldn't use law of sines before was we didn't have side G to have that full ratio. Now we do. So now for step 2, I can use law of sines to find one of my missing angles. So I'm just going to put here for step 2, find either angle F or angle H. It doesn't matter which one you find first. I'm just going to choose to find F first, go alphabetical order. But it wouldn't matter. But I can use law of sines to do that because I now have a full ratio. So I'm going to set up my sine of G over G. So sine of angle G is 82 degrees over side G is 6.7 equals, and if I'm going to choose to find angle F first, I'll set that equal to sine of angle F over side F is 6. And then I can use law of sines like we did the past couple of days to find angle F. So find the cross product, set them equal. So 6.7 times sine of F is equal to 6 times sine of 82 degrees. And then I would have to divide by 6.7. And we talked about this yesterday. If I then have sine of F equals this whole thing, how do I solve for F? Inverse sine, yep. So F is going to equal inverse sine of 6 times sine of 82 degrees divided by 6.7. And remember too, this is, I don't know, it's a minor detail, but at the same time it's not. So I know this looks like you're multiplying by a sine inverse. That's not what you're doing. You're taking sine inverse of each side. It's like taking a square root of each side. You don't multiply by a square root, you take the square root. So just make sure when you write it, you should not write after this times inverse sine. That would be an incorrect way to write it. Even if you're doing the right operation, I still want you to understand when you write it down that you're not multiplying by it. But if I type this in, inverse sine of 6 times sine of 82 divided by 6.7, equals, and if we round to the nearest degree, it'd be 62.4, so about 62 degrees would be angle F. All right, and then we still have angle H. How could we find angle H? Yep, so 180 minus angle G, so minus 82 minus angle F of 62. So angle H then would be 36 degrees. Okay, so we had to find 3 different measures. We used a different calculation to find all 3. So that's part of this practice. I'll usually see at least a few students when they have to find angle H, they use law of sines again to find angle H, and that's not wrong. Just realize you're doing more work than you need to do, and that just comes with practice recognizing, oh, I could just do this simple subtraction versus having to do law of sines again. So ultimately, I want to see that you can get the right answer however you do it, but I also want to make sure that you're using the most efficient method. Any questions on example 1? So if you're given the side angle side case, you have to find the missing side first using law of cosines. Then you can use law of sines to find a missing angle and find your third angle by subtracting the other 2 from 180. For example 2, it's important, I'm going to highlight something that's written above here. Example 2, if you just take a look at that, we're given triangle ABC, we're given the 3 sides A, B, and C. So when you're given all 3 sides, obviously you have to find all 3 angles. It does matter which one you find first. So let's see here, the second sentence, so all 3 sides we have to use law of cosines because again we're not going to have a full ratio for law of sines. But the first step is to find the measure of the largest angle. So you have to identify which of your 3 angles would be the largest and then find that one first. And this is done to ensure that the other 2 angles are acute when you use the law of sines. Another way to think of this is you're preventing what we did yesterday. You're preventing the ambiguous case. So if you were to not find the largest angle first, then you'd have to also go through the entire process we did yesterday and make sure that you can get a triangle or that you can only get 1 and not 2. But if you find the largest angle first, you're preventing that ambiguous case from happening for when you do law of sines in the next step. So I'm going to set up or sketch this triangle ABC. And label my sides. And so as it said, we're finding all 3 angles, but we have to find the largest one first. So which angle, how can you tell which angle is going to be the largest in a triangle? So this is more review of geometry. Yes. Yes. So the longest side, which is side B, the longest side is always opposite the largest angle. So angle B is going to be the largest angle. So we have to find angle B first. So I'm going to put here, step 1 is to find angle B, largest angle. Okay, and then because this is in terms of A, B, and C, the variations of law of cosines we have on the front, we could just use those. We have to use the variation that includes angle B in it. So we have to use the second one, the B squared equals A squared plus C squared minus 2AC times cosine of B. I'm just going to write that on this side so we don't have to keep flipping. Okay, and we can fill in our three sides. And I'm going to square the numbers right away. So for b squared, that's 11 squared. So that's 121 equals a squared is 25 plus c squared is 64 minus, I'm also going to multiply the 2ac right away. So 2 times 5 times 8 is 80. And that's multiplied by cosine of angle B, and angle B is what I don't know. Okay, so then I have to solve this equation for angle B. And again, this cosine of angle B is multiplied by the 80. So what would I have to do to this equation if I was to get angle B alone? Solving for angle B. Yep, eventually I have to do the inverse, but I have to get then cosine of B alone to do that. I see what you're saying, bring this over and the 121 over. So I could do that, or I could rather than switching these, I could just bring these over here rather than switching the two sides. So what's important for you to realize here is I have to, in order to get cosine of B is like x. I have to get this alone. I have to get rid of what's being added and subtracted to that term. So I'm going to subtract the 25 and the 64 from both sides to cancel those out. I don't want to add 80 because the 80 is being multiplied. So adding 80 isn't going to cancel it out. So I have 121 minus 25 minus 64. And that's 32. I still have the minus sign, so it's negative 80 times cosine of B. Then I can get cosine of B alone if I divide by negative 80. Okay, this you can certainly simplify or even divide. I'm not sure how this one works out. It does work out to be a nice decimal. If this, though, is a repeating decimal, I would leave it as a fraction in this step. Don't round it. This does end up being negative 0.4. But if it was like 0.4 repeating, I'd want to keep it as the fraction, and you wouldn't have to simplify it. That's equal to cosine of B. So then, as Carter said, once you have that alone, then you're going to have to take inverse cosine of both sides. So angle B is equal to inverse cosine of negative 0.4. And that I can calculate second cosine. Make sure you do put in there negative 0.4. The negative does make a difference. And if I round this to the nearest degree, so it's 113.578, so it'd be about 114 degrees. That would round up. So angle B would be 114. Okay, any questions on finding angle B? Okay, so then for the next step, again, you only have to use law of cosines once. I certainly could continue using it, but now for law of sines, I have a full ratio. I have sine of angle B over side B. So I can set up, this would be step 2, sine of angle B is 114 over side B is 11. And now between the next two angles I have to find A and C, it does not matter which one you find next. So you have to find the largest one first using law of cosines. The one you find next doesn't really matter. So I'll find A next. So then I would set this equal to sine of A over side A is 5. And then solve this proportion for angle A. So set the cross products equal 11 times sine of A equals 5 times sine of 114. divide both sides by 11, and then that's going to equal sine of A, so then take the inverse. So A will equal inverse sine of 5 times sine of 114 over 11. And angle A then to the nearest degree, so it's 24.534, so 25 degrees, rounding that up. And then once you have two angles, you don't need to do law of cosines or law of sines, just subtract them both from 180. So 180 minus 25 minus 114 means angle C then would be 41 degrees, approximately. Okay, any questions there? Great. So then that would make this 24. Yeah, that would be fine. So if you're off by a degree because of that, as long as I can see, like I would see in your work, oh, you found angle C first instead of angle A, that might happen, but that's okay. Yep. Okay, so then the last example, this is where, notice the I can statement, I can choose methods to solve triangles. So this is where you'd have a triangle or you'd set up a triangle and then you have to determine what method should be used to solve for what you're looking for. And you might even have a problem that doesn't require you to find everything that's missing. You're just either looking for one side or one angle. So it does say you can use law of sines and law of cosines to solve problems involving oblique triangles. I mentioned that word before. A triangle that does not have a right angle is an oblique triangle. And as I also said, you have to know at least one side and then any two other parts. But you would have to decide if law of sines or law of cosines is appropriate to use. So for example 3, I actually want you to work through this one. So it says Amelia ran 6 miles in one direction. She then turned 79 degrees and ran 7 miles. At the end of the run, how far was Amelia from her starting point? So I want you to work through actually setting up the triangle. I'll walk around, make sure you can get the right triangle set up. And then based on the information you have, determine if law of sines or law of cosines should be used to find what you're looking for. You are not solving the entire triangle in this problem. You're only looking for one piece of the triangle. So take a moment first to set it up. I can check that you have it set up correctly before you start calculating things if you'd like. Okay, so I'm pretty sure everybody has the triangle set up correctly. When you're ready, you can check that you have the correct answer as well, since you were done and had the correct answer. Okay, so pay attention in a problem if there's only one part of the triangle you have to find, or if you have to find everything.